Hi folks, how are you? I think you're having a great time. So since morning, I think you were able to witness a lot of great sessions. So I think this is also going to be fun and very informative. So I'm Asanka Nissanka. I'm VP Technology at Shoutout Labs. So a little bit about myself. I'm actually from a company that started, from the first beginning, and we have this product which is homegrown and it's been running 100% on AWS, and it's been more than 7 years I've been working with AWS services. Okay, so here's my plan for the day. So I'll be first talking about what serverless analytics is. I think you have probably heard the term serverless enough for today, but anyways, I'll be stressing on serverless in the analytics space. And then I'll be talking about the data pipeline and the different stages within the data pipeline, like the collect, transform, store, and then query and visualize. Then finally, I'll go through a couple of example solution architectures, and we can end up with a Q&A. So before I move into the in explaining about what serverless analytics is, let me briefly make a few clarification on serverless versus the managed service, because this is the kind of phrase we get when we hear these two terms. Because in most time people having hard time understanding what the differences of these two services. So I would say serverless services are managed services, but not all managed services are serverless. So what that statement says. So it's like serverless is special kind of managed service. So the main difference I see is in the serverless service, you don't see actually the underlying servers running, but in the managed service, you would see that there's a cluster and there are multiple instances running, but it's managed. You don't have to worry about the management. Okay, so why is serverless analytics? I think you have already heard, why the serverless application is important and what are the benefits we are getting from serverless applications. So all these things now you already know. So let me come to the analytics space. So when we call about analytics, we are talking about a lot of data. So a lot of data coming in, we are running several queries, different type of queries, and then all these things need to be reliable. And when you are getting a lot of data coming in to the platform, your whatever the analytics solution or the application should be capable of handling large amount of data, and it should be reliable enough, and it should be fast. The performance should be high. So for all these, considering all these things, there are plenty of open source applications, open source frameworks that we can use for high volume of data. However, it's really painful. Actually, it's really painful to running this system by your own, deploying these systems and your own infrastructure, because that's a hell of a headache. So especially for a starting up company, that is out of their scope and it's too expensive for them. And the other thing is data is changing every day, and our analytics applications also should be adapting. So we should actually spend a minimum amount of time defining or creating analytics pipeline or analytics application, because it's subject to change in near future. So it should be adaptable. And other thing is, so when you are starting a business or when your application is running idle, you don't have to pay for idle resources if you are using serverless. And same as the other serverless services, the benefits are there. It automatically scales, and then implementation is simplified, and availability for all drones is none of our concerns because it's already managed. Okay, let's go to the data pipeline. So this is a typical data pipeline looks like. So it has multiple stages like the collect, transform, store, query, and visualize. Sometimes we don't exactly need all these steps, like the transform is optional sometimes, and sometimes we implement applications or we use services that do multiple of these stages. Anyways, I'll go through to each of these stages and talk about what are the AWS services available to get that step implemented. Okay, where is data? So data collection is the most important part. Data can be anywhere. So it can be within your mobile applications, within your web applications, or data can be already stored in your databases. And data can be even not only the application directly what we are generating, I mean, not only the user data, but also the application level data. It can be logs. So they store they reside in your servers. And then it can be the devices. So devices is nothing but the IoT devices, we call them. They generate a lot of data. So they can be coming from those devices. And then it can be from your third party application, because nowadays application ecosystems comprise of several applications. Can be third party application, PaaS platforms, SaaS platforms. So your solution, your overall solution is a combination of all these things. So your data, your customer data and your business data can be in those places as well. And it can be in different formats. It can be in JSON, it can be a CSV, then freeform text, it can be images, videos, and audios. Okay, so what are the available options within the AWS space for ingesting data? So I have mentioned actually this is not the only services, but there are several other services also within AWS we can use for data ingestion. However, I picked only a few, especially the most common ones that are used in the serverless analytics pipelines. So one is the Amazon Kinesis and EventBridge, IoT Analytics, CloudDodge, Amazon S3, Amazon SQS, SNS, DataSync. I think probably you have heard most of these services already from the previous sessions. However, I give a brief about Kinesis, EventBridge, and then IoT Analytics. Okay, the EventBridge. EventBridge is actually a great solution recently introduced, and it is a serverless event bus which can connect your own applications and the SaaS applications and also the AWS services together. So it's really scalable and support high throughput and high volume of data. And it seamlessly integrates with AWS services, and also it has inbuilt integration with several partner sources like the Zendesk and then PagerDuty likewise. And how we can use EventBridge to bring in data to the our AWS ecosystem, data pipeline. So there are multiple options. You can either use the API comes with the EventBridge, or the SDK for popular language. They have the SDK already, or else you can use the command line interface to ingest data. And other thing, like I said, partner event sources. So you have AWS has already integrated with several partners, and it's readily available. It's a matter of fact, like you go in there and click few buttons and then configure with your partner source. Then it will automatically start sending those events to a custom event bus, that's partner specific event bus we have within our AWS account. And it by default connects with AWS services, and the events generated from AWS services are by default sent to a default event bus. And the great thing is it has inbuilt schema registry. So why we need a schema registry? Schema registry is when we are working with a lot of data, and when we have multiple versions of our data objects or the data classes, we would say. So when we are going through a production system, it's a good practice always to keep track of our schemas and what the changes are. And when we are building our own applications, the processing applications, we need to have mapper classes or the classes that would map with the data we have in the event bus or whatever the ingest pipeline. So we need to keep a track of all these things, and EventBridge has its own schema registry. And the other cool feature is it can distribute events to one or more targets. So it has this model called rules, where you can define, and you can actually define some filter criteria as well. You can filter out all the events coming into the platform, all the events coming into the event bus, and then you can select few events and send them only to certain targets. So this is how it works. So AWS services by default it connects with default event bus, and then custom events you can either create your own event bus and send it there, or else you can send it to the default event bus. And the SaaS applications, they comes with the pre-built integration, and if they would create, once we integrate, they would create a partner event bus within our account. And all these things you can control with rules, and there are actually several services that integrates natively with these rules. So you can send data to the Lambda, or you can send to a Kinesis data stream, or else you can send it to a SNS, SQS, and there are several more. Next comes the Kinesis. So actually, Kinesis, there are a couple of products under the Kinesis name within AWS. So one is the data streams, and then data firehose and data analytics. And recently, not that recently, sometime back, they introduced the video streams as well. So Kinesis, in the core, it's a streaming service which supports collecting, processing, and analyzing video and both data streams in real time. So it's a really like topic-based system, I would say. You can create multiple streams. It supports high throughput, and you can send both data and videos. And currently Kinesis streams, and for the ingestion actually I have highlighted these three, like the video streams, data streams, and data files. These three services of Kinesis we can use for data ingestion. And how can we ingest data into the Kinesis? We can use the streams API because they have created a dedicated API library which supports the buffering and all these things in build, and we can use that to send data to the Kinesis streams. Or else we have the producer library, and we have the agent. Agent is actually a sort of like an application that can run within your servers and continuously monitor, let's say, a log file. And then once the new entry is added to the log file, you can automatically send that and synchronize that with the Kinesis data stream. So it will send those new records into the data stream. Then we have the AWS IoT. So the AWS IoT core, there's an option for creating a rules, and that rule supports sending out that IoT data collects in the IoT core to the Kinesis streams. And the other thing is CloudWatch events and logs. Okay, the other part is IoT analytics. IoT analytics again supports collecting and processing, enriching, storing, and analyzing all these activities of data pipeline. And it can use for visualizing IoT device data at scale. And the great thing is it has this built-in data store which is optimized for time series data. So there's something called actually Kinesis Analytics as well. I'll come to that later. However, do not get this confused because IoT Analytics, as its name suggests, it's optimized for IoT workloads. So when we take IoT, so there are several devices, lot of devices sending data in the time scale. So for an analytics solution that is optimized for IoT, what we need to mainly do is this data come often with a very few amount of data attributes, and we need to enrich. So data analytics supports that, and it has its own store because we need to optimize time series data to store this IoT data. So it has this built-in SQL query engine to query data, and the other great thing is it integrates natively with SageMaker notebooks. So you can take in a data set from the IoT analytics and then further analyze it using a Jupyter notebook. And you can run your own algorithms, you can find patterns, you can visualize them, you can graph it, a lot of things you can do. And IoT analytics currently can receive data using the IoT message broker. So if you have worked with IoT core, you can connect your devices to send to the IoT core. IoT core is what we call the message broker, and message broker we can configure to through the message broker we can send the messages or the events to IoT analytics, or else IoT analytics has its own batch put message API. Then S3, I think you already know about this service. I'm not going to detail about this service because you know what S3 is, because this is one of the most widely used service within AWS. It's an object storage service, and simply put, it can store data, and we can send data using the AWS SDK and API or as the CLI and AWS services. And many of the AWS services actually directly or natively supports integration with S3. You can, for example, Glue. So Glue supports S3 for reading data and also for storing data. And we can store unlimited number of data. So this is really important because it's actually data volume is not a concern when you are using S3. And S3 is capable of, in big data pipeline, the great thing with S3 is we can, we can use S3 through a HDFS interface. So in a Hadoop-like environment, we can use S3 uh, through a HDFS kind of interface. Okay, let's go to the next stage of the data pipeline. Now the transform. So as per the transform, what we need to do. So in terms of transformation, we do several activities. We would need to either enrich data. That means what we are getting from the external service or the device is very few. So we need to enrich that data. Let's say using a device ID, we need to add all the device details also. So that is what we call enrichment. So we gather data from, we get data from an external source and then merge it with the original event. So we can enrich likewise, and we do conversions. Conversions can be either format wise or structure wise. So we get data in a certain format and we want to convert that before we are doing any further analysis or before we are storing, we need to convert that to a different format. So most time we format this to make the query easy and efficient. And we do aggregation. So we have multiple data sources coming in and we want to merge these two sources and then get a single source. Or else this cleansing. So if we are getting unwanted data which is not required for analytic purposes, we can cleanse data. We can remove unwanted attributes. So the main service I would talk about here would be the Glue, Lambda, and the Kinesis data analytics. So let's start with Glue. So Glue is a managed ETL service. So what does ETL stand for? ETL stands for the extract, transform, and load. I think during the morning presentations also you heard this term and you heard about this service. So you, I think, probably have a sort of understanding about what Glue can do. Anyways, Glue is a fully serverless solution which has a built-in metadata store. We call it as Glue Data Catalog. So data catalog is uh, we can we can identify it as just a log kind of thing, not like the application logs, but it's a data log we have. So when we are connecting data from multiple sources, we need to know what's the structure, what's the schema of this data, and what are the attributes it has. So all these things we need to store somewhere before when we are querying, because when we are querying, we need to know what are the fields to run the query against. So this is what the Glue data catalog does. And then it has the capability of automatically discovering and categorizing data. So it has the feature called the crawlers. And for example, let's say we have our data within Amazon S3 and we can run a crawler, Glue crawler against that data. And that what the crawler does is it has its inbuilt classifiers. It uses several of its inbuilt classifiers and identify what are the data and what are the structure of the data and what are the data types within that S3 source. And the other great thing is, as per the ETL, that means the transformation, it can generate the boilerplate code for cleaning, enriching, and reliably moving data between stores. Uh, so what that means is we can create the boilerplate code that is required for the ETL task. And if we need to customize it, then we can further customize it and then run it within Glue itself. And Glue run these transformation jobs in a serverless fashion. And it's really fully managed and scaling is not a problem. Then Lambda, I think Lambda you heard enough time today. So in the analytics space, Lambda plays a key role because now actually Lambda has the timeout, which is, hold on, Lambda has a timeout which allows us to use that for analytics pipelines. So we have several options that in a fully serverless fashion, all our transformation functions we can run using Lambda. And as you already know, it automatically scales and configurable concurrency. And again, Lambda also one of the most widely used service within AWS. Okay, next for transformation, we can use Kinesis Data Analytics. Kinesis Data Analytics is a streaming ETL service. So we talk about non-streaming kind of ETL service within Glue, and Kinesis, as we know, it supports data streams. So Kinesis data analytics is what we call a streaming uh, extract, transform, and load service. So what that means is when the data comes in the real time, we can run transformation or some queries and do some manipulations to the streams in real time, and then output it to a data store or to another stream for further analysis. And as of now, it supports for the transformations, it supports SQL and also the Apache Flink runtimes. And that's really great because the support for SQL makes it really easy to start with creating analytic pipelines and processing application, because it's the standard SQL that everybody knows. So you can write some queries against, you can just query a data stream like we're querying a database. There are minor changes like few additions to the in terms of the stream. However, it's the same thing that you're running, and then you can create multiple out output streams and connect it with other data sources, or you can ingest into a further analysis. And Apache Flink is really scalable and really good open source solution that runs within Kinesis data analytics, and it has a lot of flexibility over creating transformation logics. And for Kinesis data analytics, we can ingest data from data streams or data firehose. And it has this great feature of discovering the schema using the recent records. So once we send a couple of records before we start writing the Kinesis data analytics application, it would give us all the schema of the data it receives. Then comes the IoT analytics. So as per the processing, IoT analytics supports data enrichment from external data sources, and it has this concept of pipelines. So if you are creating a pipeline, you can do multiple actions, multiple activities for that pipeline, and you can make certain transformation to the data that is coming in. Like you can enrich it, you can remove certain fields, you can add new fields. Likewise, it has the inbuilt transformation activities. It's a matter of just configuring that in the console itself. You don't have to write any code. So you can just select the activity. Let's say, for example, add attribute. You just select the activity add attribute, and then you define what the attribute is, and whether it's computed, you can compute it from the other attributes you have. And other great thing is it integrates with SageMaker and for further processing. So I think I explained this earlier as well. So let's move to the next step of data pipeline, store. So this really is actually here I have actually, as per the storage, I have considered only few services in AWS, especially considering the serverless fact here. So I picked only few services that are really serverless and which are optimized for analytics workloads. Because when it comes to analytics, we have actually several type of databases like NoSQL and SQL databases, MongoDB, DynamoDB, all these things. But when you are running analytics, most time the preferred way is running SQL, because it has a lot of flexibility and it supports large scale. So within AWS, you have obviously the Amazon S3 and Aurora. Aurora is a serverless database, serverless SQL database, which currently supports both Postgre and MySQL. And other option is, if you are in the IoT space, you have the data store, which is a time series optimized data store within IoT analytics. So like I said, the main concerns here is we need to be able to handle large volume of data, and then we need to able to query, because we are running our all analysis and then visualization queries on top of this data. So whatever the data engine you are selecting, it should be able to query, and it should be flexible enough to query in different ways. So okay, so since we talk about the query, the next step of the data pipeline is query. So now that you have collected the data and you have transformed it and you have stored it somewhere, and Now you are going to build the, you are going to do the analysis. So as per the analysis, uh, Amazon Athena and Amazon Redshift Spectrum. So these are the two main services in terms of query, because for example, you might think that the data store, serverless Aurora, it has its own query interface and you can query data from it there itself. Yes, true. You can use it. But if you are using a file-based storage like Amazon S3, there should be a way to query that data. So that's where the separate query engines come into the picture. So you have the options of Amazon Athena or Redshift Spectrum. Actually, why I have mentioned, I mean, specifically Spectrum is because Spectrum is the serverless option, which can actually directly read from Amazon S3 data sources and then run queries and in a serverless fashion. So normally, if we take just Redshift, it has it's a managed service, but again, it has a cluster of instances. So in Redshift Spectrum, it's fully serverless. And whatever the query engines, these also, it's actually, if we think about the small set of data, it's not a big deal of querying that. But if you're talking about large set of data, whatever the query engine should be capable of running queries against billions of data, terabytes, petabytes of data. And it should be able to, it's great if it is capable of running the queries where the data is. If it is required to copy the data to somewhere else and then run the queries, it's not an optimized way, because these are large data sets. It's not easy to move data from one place to another. So whatever the query engine, it should be capable of reading data from where it is. And these both services are capable of that. And they comes with a standard query language which support common data formats. Okay, little bit about Athena. So Athena is a query service that is built on top of Apache Presto. Apache Presto is a very popular query engine, and it supports the standard SQL language, and really famous. And under the hood, Athena runs Apache Presto for running the queries on top of the S3 datasets we have. And it directly, like I said, it directly query the data from where they are, and we don't need to load or move data to anywhere else for it to query. And then it supports a variety of data standard service that built on top of Apache Presto, and it can directly query data from where it is. And as of now, it has the support for standard data types like CSV, JSON, and Avro Parquet, and it integrates with Blue Data Catalog, and that is how Athena knows which attributes to query from. So in a query, in a query service, the main thing is they need to know what are the data types and what are the data attributes, and what on top of what data attributes we can run the queries. And for that, Athena use Blue Data Catalog. And the other thing is Athena has a JDBC and ODBC connection out of the box, so you can connect it with other BI tools. So if you have your own visualization, you have your own BI tool, you can connect it with Athena, and just like you're querying a JDBC source, you can read data from Athena. Then Redshift Spectrum. Redshift Spectrum is again runs SQL queries again data in S3, and it's really fast, and it has a large scale, exabyte of scale, and it's elastic and highly available. It's on demand, it's high concurrency, and then again that also it's capable of integrating with Blue Data Catalog. Actually, the great thing in Blue Data Catalog is that it has the Hive compatible interface, so it can be integrated with even the EMR. Not mentioned it here, but it has the capability of integrating there as well. Okay, we have come to the final stage of the data pipeline, visualize. So for visualize or the business intelligence, you have separate couple of tools within AWS. And the great thing is when you're building a serverless analytics solution, like using these services, you have the capability of connecting with any BI tool out there, because most time BI tools supports connection from SQL or JDBC interfaces. And the analytics pipeline that we were talking about mainly comes with the JDBC connection. So you have, as AWS options, we have Amazon QuickSight and CloudWatch. So QuickSight, as its name suggests, and as we all know, it supports creating dashboards and then query data from different sources. So it has inbuilt support for integrating data from different sources, and we can access control. We can, because when it come to BI tool, we need to give access to the data guys or the business guys who's playing with data and then jumble it and create different visualization, get business insights. So it's a separate set of users, and we need to give access for them to run all their queries using a BI tool like this. So Amazon QuickSight is capable of that. I'll talk detail about QuickSight, and I have mentioned CloudWatch. You might wonder, because most people identify CloudWatch as per the logs and monitoring kind of things, but CloudWatch has this feature for creating custom dashboards. I'm not sure how many people have tried that, but that's really good, because if you are collecting data from your infrastructure, even if you are collecting data from your own applications, you can create, you can put them as, you can record them as metrics or data points within CloudWatch, and you can create custom dashboard within CloudWatch. And of course, you can create third-party BI tools. So QuickSight is a business analytics service, which is easy to visualize and explore data. You can create data stories, and you can create dashboards. And the great thing is it supports built-in integration with AWS services, and it also has the support for several other services. It's also fully serverless, and actually it's powered by this Spice. Just for the record and for your knowledge, it's a super fast parallel in memory optimized calculation engine. And okay, to the final stage. So we will talk about a few example solution architectures using the AWS services we just talked, and then walk you through a couple of solution architecture, what we can build. I mean, what type of serverless analytics pipelines we can build. Okay, so I'll start the first solution. This is actually something I have tried. So using the EventBridge mainly. So EventBridge, it connects with Mongo Atlas. Let's say you have a MongoDB database within Mongo Atlas, and then Mongo Atlas has this feature called stitch applications and triggers. So EventBridge supports natively integrates with Mongo Atlas, and you can bring we call it that actually you can get the event log of all the operations running on top of your MongoDB collection. So you can get that as a stream using the EventBridge, and then that would create a custom event bus, and you can define a rule where you want to send the data. So we actually once had a use case of message service in which we are getting millions of messages within few minutes. So we actually stored that in a serverless fashion within within the MongoDB database, and then we wanted actually near real-time analytics to be built on top of the messages we are receiving. So we had a separate, actually, like the asynchronous process separate to the main processing of the messages using the EventBridge, and using rule all the new events, like the new inserts or new data element additions to the MongoDB collection, we are getting as events, and to a rule we sending it to a SQS, and there we connected the Lambda function which runs some transformation logic, and then store it in Aurora serverless database. And through that, once we store that analytics, I mean, whatever the transformation or whatever the derived data within the Aurora, we used the QuickSight to query from Aurora and then visualize it. Okay, let's go to the solution 2. That's the same setup, but I have changed the processing path. As you can see, it's the same setup that we are connecting from the Mongo Atlas and getting events, and then from a rule, like I said before, the event with rules capable of sending the same data set to multiple targets. So in addition to sending to the SQS for different type of, let's say that we need to analyze a windowed query. What windowed query is? Okay. So let's say, for example, we are getting a inserts, so we are getting messages at a high rate, and we need to know how many messages came through during the last hour. So we do we can aggregate all the last it's like a moving window. For the last span of hour, we collect and count all the records, and we store it separately like hourly task. Or else we need to keep track of the rates, we can use that. Or else, let's say for example, we are storing only some hourly aggregated numbers, like how many messages came in this hour, how many messages in after that. So it's like a tumbling window, we call it. So we can use that and then store that data separately. So here actually I have used Kinesis Firehose, which would store all these messages in S3, and then we use Glue data catalog. We use a crawler to create the Glue data catalog of this data, and we are running a set of different type of analytics using Athena. So we have further processing. I mean, as a overall, on top of all these messages, we are running further analytics to identify different message patterns or user patterns using Athena. And that again, we can connect to the QuickSight, and in the same dashboard, we can visualize both the data coming from the Aurora and the Athena. Okay, this is the other solution using the Kinesis data streams and Kinesis data firehose. Say for example, you have your mobile application, you have your web application, and you want to analyze the clickstream data. And let's say you are an ad tech company that you need to analyze the clickstream data and impressions. So you can directly send all the click streams and the impressions to Kinesis data stream, and then Kinesis data stream you can connect with Kinesis Analytics, and within Kinesis Analytics you can either create SQL transformation, SQL Analytics, or else you can use Apache Flink. And after that, Kinesis Analytics, you can within Kinesis Analytics, after you do the transformations, you would send it to another stream, and that stream you can connect to a Lambda function. So each time that you put into that, after the transformation will be put into an internal stream, and then that stream is read by the Lambda, and the transformed or the aggregated data is stored in Aurora again. And on the other side, let's say you have a server which has a legacy application, or it has a let's say Apache web server or else Tomcat web server, and it has these access logs. It has Tomcat logs or the Apache logs, and you need to analyze these logs for identifying, let's say at a later stage, you need to identify the traffic patterns and the traffic pattern on your services and any like fraudulent service users. So for that purpose, you can use the Kinesis agent installed within your server, pointing to the log files you need, and then Kinesis agent would put that events or whatever the data added to the log files either to the Kinesis data house or the Kinesis data streams. And if you are putting it in Kinesis data house, optionally you can do a transformation using Lambda function. Let's say for example, that log file, you don't need to store it as it is, but you need to convert that to a different format, like a optimized format for query. And then so for that you can use a Lambda function, and then the transformed data you can store in the S3. And the other thing would be transform data you can further analyze with Kinesis Analytics. You have the both options, and the same flow is there once you put in the S3. Yeah. Okay, I think that's all I have, and that's another solution. Okay, I think we can get some Q&A. I'll leave this solution, and I'll be sharing the slides later on. You can look at all these solutions. Okay, I think we have one question. Let's see. Okay, so what are the Athena performance issues unlike full database products? It does not have its own optimized storage layer, therefore its performance is strongly dependent on how data is organized in S3. Okay, and if data is sorted to allow efficient metadata filtering, it will be performed once, and if not, some queries. So okay, actually it has put a reminder and a statement here. this is actually how the Glue or the Athena works. Like it depends on our how we query the data. So when we are storing data within S3, and if you are thinking what, and thank you Dinesh for sharing this thought and this really important fact. So actually, I didn't want to go into the deep of service, but since he has mentioned it, I'll explain. So Athena, like I said, it's directly querying on the S3 data. So in order to make that queries really performant and then faster, we need to know what are our data access patterns. So how we are going to query that data? Is it from the date? Is it from a different device ID? Based on that, we have to partition the data. We have to organize the data within the S3. So in that way, like for example, if it is queried by the time date, then we can put a folder name year. Then within that we can put a folder name month, and within that we can even put the day. And then after that we store in that nested folder. So when we are querying time-based query, Athena easily can find out where that particular records are. So that's actually how we are modeling the S3 folder structure as it is relevant for Athena. And thank you again, Dinesh. Okay, I think we have no more questions. So I think you guys, this session was informative and you guys learned something. Okay, thank you very much. Have a great day.